Welcome. This is another experiment to obtain better insights into the foreign function interface capabilities as offered by Rust. The foreign function interface, FFI, is an inter-language communication mechanism. It allows a component written in one language to avail the service of another component written in another language. So basically it aims to enable reuse of functionalities between components. Today I write a simple counter, a pattern counter I call it. It will be a component in Rust and show you a way to invoke this functionality from Python or Ruby. So the message is that I respect every language and I love every language. It is not to prove a point here that one language is superior to another language. I go for FFI when I want to reuse a functionality. It has been already created, tested, and up and running. So because conflicts and hostility are caused by the lack of understanding, so no benchmarking here. Every language brings certain ease to the programmers and to my community. So the agenda of the session today is it's a 5-point. First, we are going to have a different flavor of cargo today, another capability of cargo, followed by a brief on Rust slice and string slice. And we are going to use the idea we gained in this Rust slice and string slice to create a pattern counter, and which will become a library that will use the aforesaid ideas. And later this pattern counter will be turned into a dynamic library, and this dynamic library will be used for showing you the interoperability between two languages. So for example, we are going to create a Python client to invoke this functionality, that is counting the number of occurrences of a slice or pattern in a file, followed by a recap. Okay, what is our conventional wisdom or intuition about a slice? It's natural for us to think of a slice as a carved out portion from a bigger piece. Let us proceed with our intuition and perform an experiment to assess or align our intuition with the reality. We created a project, slice play, and the slice play, let me create an array of type i32 and the length is 10. Now I am going to obtain a slice of these three numbers 3, 4, 5 using a range operator. So if you want 3, 4, 5, then we have to give one number ahead of this. So we mean this as a slice, and let me name this variable as slice, and we got an error, does not have a size, not at compile time. Not yet saved this. Okay, so the first observation is we are unable to carve out a slice from the array. In other words, we are not permitted to own the slice of the array. So owning means without using an ampersand symbol. If I put an ampersand symbol here, the error is gone. So what is the second observation is we are allowed only to hold the reference of the slice. Meaning we are allowed only to borrow a slice, not to own a slice. Let us do the second experiment. Now I ask more than what is available in the array, that is from 3 to 20, which is beyond the boundary of this array. If I compile, it is saved. Not an absent-minded one now. Cargo build. It's compiling. No errors. But when I run this, see what happens. We are getting an error at runtime that the range index 20 is for slice. So it Rust itself have accepted our adventurous. This is a slice, and we are trying to seek more than what is available there. So what is the observation? The Rust compiler defers the size checking to the runtime, not during the compilation time. The compiler does not care about the exploitation, but we are getting an error during the runtime. So the Rust compiler defers size checking to the runtime. That's the second observation. So the first observation is we are allowed only to hold the reference to the slice. In other words, we are allowed only to borrow the slice, and the Rust compiler defers a size checking to the runtime. Let us do another experiment. Now, I own this array in its mutable form. And I borrow the slice in a mutable form. So this array is owned in its mutable form. This slice is borrowed in its mutable form. So this is ampersand mute, so that I can make some modification to this slice. Let us change the first value to 99. That is, this will replace the value 3 here as 99. Let us check. Okay, absent-minded 3 to 6, so that includes 3, 4, 5 alone. Let me run this again. 99, 4, 5, successful. Let us check what is now in this array. That will be very interesting. Wow. So what is observation? We borrow the slice in a mutable way and change the value of an element. The change is reflected back into both the borrowed portion and the whole portion. I guess these 3 experiments of borrowing a slice through the reference and asking for more than what is available in the source, and making a modification to the slice and its reflection back into the parent array. This gives us a lot of insights. 1. Slice is not a carved out portion. It is not carved out. That's what we originally thought of. Had it been a carved out portion, the changes will not be reflected into the whole. the connection between the sliced portion and the source is completely intact. So slice is clearly exhibiting the behavior of a pointer. Slice cannot be owned but can only be used in its borrowed state using the reference operator ampersand. Let's check for one more thing. As we are accessing the slice in its mutable form, after this array, let us just remove this. That is a different game. Now let us check if it has a length and what is a length. Yes, the length of the slice is 3. So your slice has two things. It is exhibiting the behavior of your pointer because I am able to, when I am making a change to the slice, it affects the parent. And it has a length property. So the combination of pointer along with a length, in Rust terminology, we call this as a wider or a wide pointer. And there is already a fat pointer that we will discuss later. We can consider this as a wide pointer, W-I-D-E, wide pointer. Now it is time to reconcile our finding with the Rust idea of a slice. So what Rust says? We'll first go to the book, the Rust programming language, that gives a hint on the utility of a slice. Another data type that does not have ownership is a slice. Clear, right? So we are using that always in its borrowed form with an ampersand. It does not have ownership. You cannot own a slice. Slices let you reference a contiguous sequence of elements in a collection. Contiguous sequence, instance of contiguous sequence are your array and vector, and it helps you to reference a portion of a contiguous sequence. This is a first idea, and this is more of a utility. So what slices let you to do, it let you to reference a contiguous sequence of elements. But this is not a definition of what a slice is. And the definition of a slice is where? Let us refer the Rust Nomicon, the dark art of unsafe Rust, and what it says about this slice. A slice is simply a view into some contiguous storage. This is a very fantastic definition that summarizes all our observation. It is simply a view into some contiguous storage, typically an array or vec. And Rust can classify this slice. It gives a special status to slice along with trait. Let us just focus on slice now. It is classified under dynamically sized types. It is not dynamic type. People will normally misunderstood this as dynamic type. It is statically typed, no doubt about this, but the size is being computed during the runtime. That's what is a second experiment that what we did. So this is what a slice is all about. Now if you go and read these two great books, the Rust Nomicon, dynamically sized types, and the slice type from the book, the Rust programming language, you may gain more clarity. Now let us apply our idea of slicing to a vector. A vector vec1, which we can create from using a vec exclamatory, which is a macro, and this is of type vec of i32, and this is also a contiguous storage similar to the array, so it should obey all the rules of slicing using a range operation. So we have created a vector of I32 and we did the same slicing using the range operation on this vec1, and there is no difference at all. As I am going to introduce now how this slicing is going to work in a string, let us take a small pause. We will put a for loop which is very primitive to travel the elements of this slice. For I in 0 dot vec1 dot len, sorry, v slice dot len, because every slice has two elements, one is a pointer and another one is a length. Now we are exploiting the length capability, and let us print. This is going to play a very important role in the subsequent minutes. Let us use the I as an index for this. Perfect. Now let us apply this trick to the string. Let me create a string first. Let us use the same slicing technique. Let us use a 0 dot 3 for safer side, f o, and I don't think r will be included or not. Let's call this as s slice. Let's print the s slice. FOR, the three letters from F. And what is the type of this S slice? This is our cute ampersand str. So this is a string slice that what we use most of our time in its borrowed form. Right? Now let us try to iterate over the string to print each of this value. So this is also a slice, so it is having already a length through the wide pointer concept. So I in s dot slice, and let us print the value at the index of s slice. So now do you see the error? String indices are ranges of usage. This is not a very useful information. The type str cannot be indexed by usesize. That is the most interesting information that we got. Now, why does Rust impose such a restriction on this slice? Why am I not able to use an index? Okay, now we will get an answer for that if we change the value of the string from an English sentence to a Sanskrit sentence, because the string is a collection of UTF-8 characters and it is not a regular single byte English character. So what is the connection between a single byte and a multi-byte characters and to the indexing, which we are going to expose now. So now I just remove this for loop. Let me check what is the length of this. Our conventional wisdom says, our intuition says that this is a 4-letter character, na, ma, is, te. But in fact, if you look into the length of this namaste, it will be, it is not what we are thinking. It's not going to be. See, the length of the slice is 3. Sorry, what I did. Let us take the entire sentence, because it was telling 0.3, which is na, that's what is getting printed here. So if I am thinking that I have traveled up to na, ma, and up to this is, but it is taken only the na, and it is printing that it is 3. So that is fine. So meaning the na alone is taking 3 bytes. So now think of the rest. How many bytes we are expecting? So if I use the complete range operation now and run this, the length of the string slice is 18. It is not as we thought that it is na, ma, is, te, which is a 4-letter or a 6-letter. It is 18. What is this 18? It is, so the length of the string slice is 18. What is the unit of measurement? It is bytes. So it is made up of 18 bytes. So, and if you look into the characters, any idea is na, ma, is, and then there is a UTF character followed by the, and then again another UTF character that is not printable. So as it is unable to print, it is just showing you the UTF 8 characters here. So na, ma, is, and then a UTF that is 5, sorry, 1, 2, 3, 4, 5, 6. So it is made up of 6 UTF-8 blocks. It is, whereas the length of this sentence is, or the slice or the sentence, whatever it is, because both of them are same now, is 18 bytes. So it is not 18 characters, it is 18 bytes, and it is made up of 6 characters. So this is the reason the indexing function is not offered directly to us. So in other words, to summarize, as we often deal with English sentences, which can be represented by a collection of single byte characters, we tend to think every language character can be represented with a single byte. That's what our intuition is. Namaste, where each of them requires 3 bytes to represent a non-English, if it is a Sanskrit, for example. So if the index happens to fall within a character boundary, the resulting cluster may convey a different meaning, or that may lead to representation of altogether a wrong meaning. So Rust is stopping us using any index. So in other words, if I use 0 dot dot 2 here instead of 3, I can expose one more vulnerability now. Now you are getting an error. It is telling you that byte index 2 is not a character boundary. It is inside na, because na itself is made up of 3 bytes. So if I provide 3 here, then it works silently. When I provide 2 here, the index happens to fall within the character boundary. So Rust is complaining you. And this is the reason why Rust is not allowing us to access a string using its index. So don't ever use the same trick that what we are using with vec and the array of I32, where we know what is the size and we can safely do some slicing using the range operator. When it comes to sentence, we should never use a range operation like this. So if you want to convert a string into the ampersand str counterpart, use the sentence and dot as str. And if you're taking this, so this is the way we have to handle a string slice. But now I didn't answer the question of then how to travel the string slice. Okay. So we need a for loop for I in or C in a slice. Let us use not a index based one, let us use a regular iterator. Let me pretend as if there is an iterator here. Yes, slice, and already I am getting an error. It is not even allowing me to travel this using the regular iterator capability that what a for loop offers. Whereas it is giving you an indication that you can either use a dot cast method or the dot bytes method. So if you use a yes slice dot cast method, it will help us to print the characters over there. So we cannot use the index, so we are using the C itself there. The value is name is, and then some appendage to that makes this into is, and the and then a hat to that makes this into t, and these are all the characters, that is what is making the UTF characters, that is what is making this 18-byte length of namaste. And let us use another interesting Tamil word, and there is Yanavum is not namaste. They are two different, they convey two different meaning. And Karguran on this, it so happened this is also 18 bytes, and the UTF characters of Yanavum is Yana, Va, and Va. Along with this, it is a U to this that makes this Va into Wu, and a Ma, and then a dot on that makes this Ma, but this dot is Im. Yeah, na, boom. Again, what is happening here? It is 1, 2, 3, 4, 5, 6 characters, and it is made up of 18. That means each of them is occupying 3 bytes. 18 by 6 will be 3. So A is occupying 3, Na is occupying 3, and Y is occupying 3. And so this is the way we can travel. This is one of the ways I can travel a slice using its cats.